This video is for section 11.1, describing chemical reactions. The learning goals are to be able to write a skeleton equation and a balanced equation. Let's take a look at that first learning goal. Be able to write a skeleton equation. Our first vocabulary word is chemical equation. This is a representation that shows the reactants and products of a chemical reaction. Here's the general pattern of a chemical equation. There'll be an arrow in the middle separating the reactants from the products, and for any specific chemical equation, the reactants will be one or more elements or compounds added together. The products will be one or more elements or compounds added together. A skeleton equation is a chemical equation. It shows what substances are involved in a reaction, but does not show the relative amounts of the substances. Here are some example skeleton equations. Notice the arrow symbol right there. H2 gaseous plus O2 gaseous produces H2O liquid. This skeleton equation shows the formation of liquid water from two gases, hydrogen and oxygen, but it doesn't indicate how much hydrogen or how much oxygen is needed. It just gives the substances. NaCl aqueous plus silver nitrate aqueous produces sodium nitrate aqueous plus silver chloride solid. This skeleton equation shows the production of sodium nitrate and silver chloride from these reactants. Some symbols used in chemical equations are shown below. The arrow symbol is the word yields or the word produces. A double arrow indicates a reversible reaction. S, the L, and the G indicate the state of the substance, solid, liquid, or gas. And AQ indicates the substance is aqueous, meaning it has been dissolved in water. If a reaction uses heat, electricity, or a catalyst, then that is written above the arrow symbol in the equation. Here's what a catalyst is: a substance that speeds up a reaction, but it isn't used up in the reaction. Because it's not actually used up in the reaction, it's not one of the reactants. Here are some check for understanding questions. I'll pause the video for you to answer these, and then we'll discuss them in class before returning to the lesson. Here's the answer for number 1. It says solid iron, that's Fe with an S after it. It reacts with oxygen gas, so you say plus and then O2 with a G after it. The word produce is the arrow, and that says solid iron 3 oxide. Iron 3 oxide is Fe2O3. The reason for that is that the iron is a positive 3 charge because of that Roman numeral. Oxide is negative 2 because it's in group 6A. It's going to take 2 of the irons to balance with 3 of the oxides. Number 2, when it says aqueous hydrogen peroxide, that's H2O2 with an AQ after it. It says it decomposes. That means it's going to split up into more than one product. And it says that it only happens in the presence of manganese oxide. So on top of the arrow, I'm going to write the catalyst MnO2. That's the formula for manganese 4 oxide. It produces liquid water, so that's H2O with an L after it, plus oxygen gas, that's O2 with a G after it. And here's the answer for number 3. Write a sentence for this skeleton equation. This piece here can be written as solid iron. When it says plus O2, there's different ways to write that, but you could say reacts with, and then O2 is oxygen gas. The arrow could be written in words as to produce, and then this piece right here is solid iron 3 oxide. For the next learning goal, let's learn how to change skeleton equations into balanced equations. A balanced equation is a chemical equation in which each side of the equation has the same number of atoms of each element. Here are some examples of balanced equations. 2H2 gaseous plus O2 gaseous produces 2H2O liquid. If this did not have the 2 here and the 2 here, then it's only a skeleton equation. saying that hydrogen plus oxygen makes water. But because of the coefficients of 2 written in front of those substances, it becomes a balanced equation because there's an equal amount of each atom on both sides of the arrow. Look at the letter H. 2 times 2 is 4 hydrogens. On the right side of the arrow, 2 times 2 is 4 hydrogens. Now look at the letter O. We can see there are 2 O's here, and on the other side of the arrow, when that coefficient is distributed to this O, or another way to think of it is 2 times 1 makes 2 O's, we see that the O's are equal on both sides of the arrow as well. That's a balanced equation when you have equal numbers of atoms on both sides. In the next example, 4 Fe solid plus 3 O2 gas makes 2 Fe2O3 solid. We have 4 irons here, and on this side, the coefficient times the subscript makes 4 irons. Look at the oxygen. 3 times 2 is 6 oxygen atoms. And over here, 2 times 3 is 6 oxygen atoms. A coefficient is a whole number written in front of a substance to indicate how many units of that substance are involved in the reaction. Here are some check for understanding questions. I will pause the video for you to answer these. Notice in this first problem there's this blank spot here. That's what I'm asking you. What coefficient has to go there to balance the equation? In number 2, there's a blank spot here and a blank spot here. I'll pause the video for you to work on these. And here comes the answer. In number 1, we have 3 carbons. So over here we have to have 3 carbons. We need to have a 3 right there. And let's just make sure that that also balances the oxygens. 3 O's here plus 3 O's here is a total of 6 O's on the left side. On the right side, as soon as we put that 3 there, 3 times 2 is 6 O's. Number 2, what goes here and here so it's balanced? Well, look at the NO3s, which we know is the word nitrate on the page 268 chart. We're told that there are 2 nitrates. So what do we have to put here so that we end up with 2 nitrates? We need to have a 2. And as soon as we do that, then we have 2 Ks. So in front, we need a 2. And let's just check out that our iodine is correct as well. By putting a 2 here, that's 2 I's. And over on this side, there are the 2 iodines. Here are the guidelines that I was following when I balanced those equations. Number 1, write out a correct chemical equation. If you don't even get the right substances or the right formulas for the substances written, then there's no way you can balance it correctly. Number 2, determine the number of atoms of each element in the reactants and the products. If the same polyatomic ion appears on both sides of the equation, then consider it as a single item. I had done that on number 2. NO3 is a polyatomic ion, and over here the NO3 is polyatomic. I considered it as a single entity. I did not separately count N's and count O's. I kept NO3 together and observed there were 2 of those. Step 3, balance the elements one at a time by inserting coefficients. If no coefficient is written, then it's always a 1. Step 4, never change a subscript because that messes up your original skeleton equation. Once you have written out the substances, don't go putting tiny little numbers in the bottom corners because no longer would your formulas fit the substances. And finally, step 5, check your answer to make sure there's an equal number of atoms of each element on both sides of the equation. If there's not, then try different coefficients. Please don't think you're always going to get the right coefficients on your first try. Sometimes you fill numbers in, and then as you check it out, you discover it doesn't actually work. So just erase them and try different coefficients. Here are some check for understanding questions. Balance each equation by inserting coefficients as necessary. I'll give you some time to work on this, and remember the 5-step process on the previous page of your notes. Okay, here come the answers. In number 1, there's a little 3 by the sodium. This has 3 sodiums. So we want this to have 3 sodiums. Let's put a 3 in front. As soon as we do that, that 3 also distributes to the hydroxide, to the OH, making 3 hydroxides. So let's put a 3 right here. That's 3 OHs. As soon as we put the 3 here, that makes 3 Ks, and that's a good thing because that's 3 Ks. Finally, let's check that our PO4 called phosphate is correct. There's 1 PO4 here, and over on this side, there's 1 PO4. So we didn't actually have to make any changes in this spot, in this spot. It's like putting a 1 here and a 1 here. It's just we don't show 1s as coefficients. Number 2, there's 1 magnesium here, and over on this side of the arrow, there's 1 magnesium. So magnesium looks okay for now. But there's 2 Fs. So how can we make this have 2 Fs? We can't put a subscript of 2. That's not how you balance. You do it with coefficients. The 2 goes in front. As soon as you do that, that also makes 2 lithiums. Well, that's a good thing because right here is 2 lithiums. Let's check out the carbonate, the CO3. There's a single carbonate here, and over on this side, a single carbonate. So the only coefficient we needed to put in there was a 2 in the last position. It's like keeping a 1 here, a 1 here, and a 1 here. Number 3. Here there are 4 phosphorus atoms, but over here there's just 2 of them. So we need a 2 in front because 2 times 2 makes 4 capital P's. Right here there's 2 O's, and on this side, how many O's are there? Don't say 3. Remember we put a coefficient in front. 2 times 3 is 6 O's. So in this spot, we need a 3, because 3 times 2 is 6 O's. Number 4, 1 rubidium, and over here, 1 rubidium, so the rubidium's fine. Right here, there's 1 nitrate. When I see the NO3, I'm seeing it as a single entity called nitrate. Right here, there are 2 nitrates, so we need a 2 in front. As soon as we do that, it messes up the rubidium. This is now 2 RBs. So over here, we need 2 RBs. That also makes 2 Fs. Well, that's a good thing because right here, there are 2 Fs. Let's just check beryllium, make sure it's okay. How many berylliums? Just 1. And right here, how many berylliums? Just 1. Now number 5. There's 1 silver, and over here, 1 silver. So the Ag's okay right now. Let's look at nitrate. There's a single nitrate here, but right here there's 2 nitrates. So we need a 2 in front. But now the silver's not correct. There's now 2 Ag's. So we need a 2 there. And let's check copper. 1 copper, 1 copper. So here are the answers for those check for understanding questions. This concludes the video about creating a skeleton equation that simply states what substances are reacting. But we also discussed balanced equations in which there's equal number of atoms on both sides of the arrow. To change a skeleton into a balanced equation, you add in coefficient numbers.